What's up guys, and welcome to today's video. So in today's video I'm going to be showing you how you can verify a smart contract, how you can deploy and verify a smart contract on Etherscan. So it's going to show you that verification check mark on your smart contract code, and users will be able to interact with your smart contract directly from Etherscan. Okay, so the first thing we're going to do, we're just going to start from a new folder. So we're just going to open this folder in our Visual Studio Code. So let's go to my command prompt. So we're going to change the directory to this folder. Then we're going to open this. We're going to open our Visual Studio Code with this new folder. So first and foremost, we have to have Foundry installed on our machine. We're also going to need a private key. It can be a MetaMask private key, any private key to deploy the smart contract and sign the transaction. We're going to need Etherscan API keys, okay, and we're also going to need the RPC URL. If you are deploying an Ethereum mainnet, Binance Smart Chain, or the testnet, you just need that URL to broadcast your transaction. Then obviously the code we're going to deploy and the deployment script. Okay, so let's just get started. So the first thing we're going to do, we're going to pull up our terminal. So this is PowerShell. I'm using a Windows machine, so I'm just going to change this to WSL. So just let it load. Okay, good. So let's clear. Now I'm going to start with Forge init to create a new Foundry project. So as you can see guys, we have created a new Foundry project. So the script, so this is the source file and this is the script, this is the test file. We're just going to delete all these default files that came with the project. Just going to delete all of them. Perfect. So let's just clear our terminal. So the first thing we're going to do, we're going to create a new file. We're going to call this KONVATI bank secured .so. This is the smart contract. So guys, if you watch my previous video, it was where I deployed a vulnerable smart contract that was actually vulnerable to reentrancy, and I also did a video on how we exploit that reentrancy vulnerability and was able to drain the contract. So in this case, I have done a secured smart contract. Let's just copy this code. So let's paste this code here. Let's take this down. So as you can see, I copied the reentrancy guard from OpenZeppelin. I added the reentrancy guard from OpenZeppelin. I also added the modifier here in this video. Then also I changed the state. So now this smart contract follows the check, effects, and interaction. So it first checks, then it does the effect, that's the updates the balance, then it now before it does any transfer. Okay, so I'm just going to save this file. So this is the reentrancy guard code from OpenZeppelin. So I just copied this and added it to my code. Okay, so let's continue. So now we're also going to create a deployment script, right? So this is going to be it. So let's just copy this code. This is the script that we're going to run to deploy our smart contract and also verify our smart contract. So we're going to come to script, new file. We're going to write deploy KONVATI bank secured .s.so. So we're going to open it, we're going to paste it here. Perfect, everything looks good. Okay, so what we're going to do now, we're going to bring back our terminal and we're going to compile this smart contract to make sure there is no error. Okay, Perfect. So we're just going to write forge build, and it's going to compile. Compiled successfully, right? So the next thing we're going to do now, in order for us to deploy, we need our Etherscan API key. Okay, so you can easily just log into your Etherscan. Once you log in, you get your API key. So now we're going to deploy the smart contract, and we're also going to verify it. Okay, so what we're going to do, we're just going to copy this line of code. So this is what we're going to enter in our command line to verify, to deploy and verify. So let's bring it up. So we paste this line of code here. Okay, so we're just going to edit this, right? So just start. For our RPC, we're just going to put in our RPC URL here. So let's get our RPC URL. So we're deploying on this deployer testnet. So we'll just copy this. We're going to paste it here. Perfect. So our private key, we're going to put in our private key because that's what we're going to use to deploy the smart contract and sign the transaction. So let's copy our private key. This is all done on the testnet. So this is our private key. We're just going to copy this. We're going to paste it here. Then for our Etherscan API key, we are going to replace this with our API key. Going to copy this and we're going to paste this here. So as you can see, guys, so this is the script. This is the line we're going to write. Forge script deploy KONVATI bank secured, then deploy KONVATI bank, that is the smart contract. Then we pass in our RPC URL, then we pass in our private key, then we pass in broadcast dash verified. The Etherscan API key, we put in our Etherscan, and basically that's it, guys. We're just gonna hit enter. As you can see, guys, it's compiling. So we'll just give it some time for it to deploy this on the testnet and verify our smart contract. As you can see, guys, it's deploying our newly smart contracts, this KONVATI bank secure smart contract. So this is a simple bank smart contract that allows deposits and also allows withdrawal. It works exactly like a bank. You can deposit your money into this bank, and you can also withdraw your money. So in this case, I'm deploying to the Ethereum testnet. If you watch my video, or if you watch the next video, I'm also going to deploy this smart contract to the Binance Smart Chain testnet. As you can see, it was successful. Our contract address is out. So what it's doing now, it's verifying our contract. Okay, it's submitting our contract for verification. But as you can see, our contract has already been deployed, and we're going to interact with this smart contract once it's verified. Okay, response. Okay, as you can see, it has successfully verified this smart contract. It has deployed this smart contract and it has verified this smart contract. So let's copy the smart contract address and let's check it. Copy. As you can see, guys, it was successful. The verification was passed and it's verified. That this is a very, very good news. So let's check this newly deployed smart contract. Okay, so we're just gonna replace this. As you can see, guys, this smart contract was just recently deployed, and if you notice here, you're going to see, look at, guys, its smart contract source code is verified, KONVATI bank secured. So as you can see, this is the code. This is our secured bank. We added the open Zeppelin reentrancing guard, and we also updated our withdrawal function to prevent it from reentrancing. If you watch my previous video, you can see the vulnerable contract that was vulnerable to reentrancy, and we're able to drain all its funds using reentrancy. So this smart contract, it's deployed, it's live on the Sequoia Ethereum blockchain, and we're also going to interact. As you can see, we can read this smart contract, and we can also write this smart contract. So we're going to interact with this smart contract. Like I said, it's a bank, it accepts deposits, and also it can withdraw deposits. It's also verified. So let's open this transaction hash. As you can see, these are the two functions, deposits and withdraw. We're going to do that in a bit. So this is the transaction hash. It was created 2 minutes ago. This was how much you pay for transaction fee from this account. That's me. It created this smart contract. Okay, so now let's interact with this KONVATI bank smart contract. First, let's deposit. Let's open our MetaMask first. That's the first thing. Let's check how much we have, and let's just do a deposit and withdraw function directly from MetaMask. As you can have, we have 0.39. We have 0.39, so we're just going to make a deposit of 0.3. So let's do that. 0.03, right? I think that was what I was supposed to do. Yep, 0.3. So let's write this. If you have any question, let me know in the comment section. Okay, if you want to contact me, head over to konvati.com/contact. So first we have to connect our wallet. So let's connect our wallet. MetaMask, connect. Perfect. So our wallet is connected. So now let's deposit. So we want to deposit 0.3. Like I said, it works like a bank. It's a very simple bank smart contract, but it's a decentralized bank smart contract. It has no centralized, like nobody's controlling it. It's not even me who deployed this smart contract, right? So let's just confirm this transaction. If you have any question, let me know in the comment section. Okay, if you want to contact me, head over to konvati.com/contact. So you're seeing insufficient gas, but I think we have confirmed the transaction before. Good. So as you can see, guys, this Ether balance has 0.03 because I technically deposited all my money. So if we check now, let's check. If you check, as you can see, we have less balance. As you can see here, this was the deposit that we did. The second one failed because there was no gas, but this was the deposit that we did. And if you come to transaction, the transaction is now loading. It should load. Perfect. You can see the transaction that I did. I deposited 0.0 Ether. This is another account, and this account has way more money inside this smart contract. So I can deposit all this money inside this smart contract because why? I trust this smart contract. This smart contract is it's a very secure bank smart contract. Okay, so if you make a deposit to this smart contract, only you can withdraw the money. So let's go back to our contract. Let's go to write contract. So we're also going to connect this wallet. This wallet has way more money. So we're going to deposit 0.13 into this smart contract. Okay, so let's come back here. Let's allow this to load. As you can see, the contract is verified. That means we can interact with this contract directly from Etherscan instead of using Foundry to send a cast, sell, and write and all of that. We're going to deposit 0.1. If you have any question, let me know in the comment section. Sorry, we're supposed to first connect our wallet. MetaMask. Let's just go back here. It was loading. Connect. So we're connecting our MetaMask to ether scan which is connected. So we're going to deposit 0.1 because this guy has more than 0.1. So it's saying unapproved. So let's come back here. Let's just go here. Let's come back here and let's approve the transaction. So we're just gonna confirm it. If you have any question, let me know in the comment section. Okay, if you want to contact me, head over to konvati.com/contact. So it has been queued. Let's come back here. Let's refresh this page and let's see whether it's updated. As you can see, guys, it was updated. Transaction, as you can see, it has received 2 deposits from 2 different accounts. So let's go back to the first account that made the deposit and let's call the withdrawal function. So let's come back to contract. Let's come to write contract. Sorry, let's refresh this page because this balance hasn't updated. Okay, good, it has updated now. So let's withdraw. First have to connect our wallet. Let's connect our MetaMask wallet. It has been connected. So let's quickly withdraw our balance. So it's going to go down from 0.13 to 0.1 ether because this guy deposited 0.03. We're going to confirm. Hopefully we have enough gas to pay. So I think it has worked. So let's just view this transaction hash. So this is the transaction. As you can see, 8 seconds ago we called the withdrawal function and it worked. The smart contract transferred 0.03 ether to the user, right? So this smart contract, it's going to have 0.1. Let's refresh this page and let us check our balance. As you can see, it has 0.1 and our balance has also increased. Let's go back to the other user and let him withdraw his money. As you can see, this user had 0.13. Now he has 0.03. So he's also going to call this withdrawal function directly from MetaMask. Let's connect our wallet. It's connected. So let's call the withdrawal function. So this withdrawal function is going to send his balance, whatever balance he has, to him. Why is it not letting me send? Let's go back to this one. You receive 0.1. Yep, I want to receive 0.1. So this is the transaction. As you can see, it's pending. So let's just allow the Ethereum blockchain to do its thing, right? And let's just watch our balance increase. Let's come back here. I think it was successful. Let's open this transaction. It was successful. Yep, the smart contract sent 0.1 back to the user because he called the withdrawal function. As you can see, it's confirmed and his balance has increased. If you like this video, give this video a thumbs up. If you don't like this video, give this video a thumbs down, but let me know the reason in the comment section below. Also guys, watch my next video. We're also going to be deploying the smart contract on the Binance Smart Chain, and we're also going to be verifying it on the BSC scan and also interacting with it. So this is the simple bank smart contract. We can develop this bank smart contract more. We can add a front-end user interface. It's really secured. It's live. Nobody has control over these bank smart contracts. Anybody can deposit and anybody can withdraw anytime, anywhere. If you want me to help you develop your smart contract or help you develop your token, just contact me. Head over to konvati.com/withdraw. You're going to be redirected to me. Just let me know how I can help you. Also guys, join my Discord group. It's going to be in the description below. Alright guys, if you like this video, give this video a thumbs up. If you don't like this video, give this video a thumbs down, but let me know the reason in the comment section below. See you guys in my next video.